Hey, Soumith.
Hey, how's it going?
So backstage, we were having a little debate, and I thought we'd kick things off just by continuing it. I think there's a lot of forces which push towards centralization for these models. In terms of serving them, there's all these advantages in terms of batching and just having a lot of users. Maybe most importantly, since once we get to the point where these models are learning on the job, you could have copies of a deployed model learning how to do every single job in the economy. And this fact, so humans, when we learn on the job, we learn something. These models will be learning what every single copy sees. Just seems like it would really benefit the person who first gets this ability, and they would be able to consolidate a lot of the benefits. And there might be other kinds of data flywheels as well. So do you think this is a dynamic we'll actually see?
I think one of the ways I would think about this is these companies are run by people, and people have limited context and limited prioritization ability. The number of things that, let's say, for example, Google could do, but they don't do despite having the people to do it, is probably just an example of why, even though theoretically these companies that are building out these models and deploying them could nearly cover every use case and scenario you probably would think of, but they wouldn't. And there would be opportunities for other companies who are just operating at a smaller scale, and their overall priorities and their margins and their mission are just much more verticalized to a particular thing. They'll just win because they care more about particular problems and verticals. If as you described, the entire company is run by AIs, if we basically go to a point where you're like, well, this entire thing is run by AIs, which have superhuman contextualization, prioritization, like the AIs can reason through like a million priorities in ways that the CEO, being a human, could never do, then I would say then that would be a very different way to reason about it. But considering like a lot of these AI companies are, for the foreseeable future, going to be centrally run by humans, I think there's limits towards how deep and how wide these AIs will get deployed into particular verticals, especially niche ones.
I feel like the idea that these different smaller companies will be prioritizing different use cases, and so there'll be decentralization, seems to contradict the bitter lesson where instead of making bespoke solutions for everything, you should just have a very general procedure where you've just dumped a bunch of the best algorithms. And yeah, if you have a bunch of use cases, if you just come up with a thing which can learn on the job, which has all these missing capabilities that LLMs currently have, it seems like the trends in AI in the past have just been that the person who scales the most has a big advantage, and the bitter lesson has worked. So why would that change?
Yeah, I think the bitter lesson doesn't take into account many considerations. It doesn't take into account individual considerations, geopolitical considerations, considerations of scale, because the bitter lesson is about a machine learning model solving a given task. It is not about intelligence that is artificial, providing utility across the world in a wide variety of scenarios. So I think the bitter lesson in that isolation of like, hey, will an ML model solve a given task or a set of tasks without taking all of these societal considerations into effect, I think would hold true that a general scaled model will probably just win the whole thing. But people like to compete, countries like to compete, companies like to compete. And in this scenario, there's a lot of like these zero-sum considerations where I don't think like the most efficient solution in isolation would be the solution that will actually get deployed in practice.
So you think the hive mind is efficient? It's just like we won't be allowed to use it.
Yeah, I mean, look at how social intelligence is distributed today. It is extremely decentralized. People don't accumulate knowledge in a singular place or form. Like even with the internet, like you just have knowledge decentralized into a bunch of websites and encyclopedias and all of that stuff. So I think that is going to continue being true as long as power is important for people to if people find agency and power to be important, to be preserved, then I think like centralization will have its limits.
I think the internet is an example where over time the network effects and the data flywheel have centralized the actual, I mean, you can go on any website you want to, but in the fraction of web pages that people visit is probably much narrower than it was 20 years ago. And I think this will be even stronger with AIs because eventually, if you have copies of the same model, they have advantages in social learning that humans don't even have, like the ability to merge their weights, to have copies, to fork, to distill, to scale. Like the CEO can be copied an infinite amount of times and just oversee every single thing that's happening in the organization, things like that. So yeah, I feel like the internet maybe does point towards some sort of centralization in AI.
I think the internet points to centralization of where the knowledge is recorded. But if you actually see, if you look at WhatsApp, Signal, Instagram, like a bunch of like online properties, people go and like create content, create information on these websites, but they don't do it in a singular thread. It's not like you have a singular group where everyone is posting. Like there's millions of threads that people join on various topics or whatever, and then they aggregate or like they create information in these threads. So like, I don't think the centralization of where the information gets recorded is evidence that centralization of information being aggregated towards. Like people still create separate threads. Like people create separate communities, groups, and all of that, right?
In this analogy, what is the equivalent of the social media platform and what is the equivalent of a single thread or a group chat?
In what analogy? Like I'm trying to understand.
In the idea that like, look, we have social media companies, and even though you visit those quite often, your like parcel of interaction is one thread of conversation, and you're suggesting that might be similar like for AI. So then, what will the thread be? Will it just be the session, maybe like the individual copy because it has some sense of memory?
Yeah.
And then what will be the platform that you got to interact with?
Right.
Because if everybody's using the one model in the way that you use one social media platform, that's still quite centralized.
I think this kind of comes back to, I think, your original question that we were arguing about backstage, which is like, will centralized AI win or will decentralized AI win, right? Like, I think it kind of goes to the core premise of it. I think centralized AI, even if you have forks and copies and like, ability to personalize, it will have to, first, I don't think like there will be a single company that will just win the whole race in a very short period of time. Now, if you agree with the premise that you're gonna have maybe 5 to 10 companies which will each have centralized AIs, and then they're gonna like do what you describe, which is like fork and aggregate and like get smarter among these experts that they're deploying and personalizing. I think there's gonna be a little bit of like this game theoretic concern where Now we're talking about AIs getting smarter by learning from like a disparate set of deployments and then like aggregating that intelligence back centrally. And I think if the value of the overall product that is being offered, say, let's say, for example, ChatGPT, is coupled into one is intelligence and the second is some kind of product integration or product specialty, and intelligence is like one of the big factors, then out of these 5 to 10 providers, some of them will want to start collaborating in order to like collectively get more intelligent together while differentiating on their product value. Some of them might only be serving enterprises and the others might be serving consumers, or some of them are serving, like say there's like one of the companies which has like intelligence specific to India way more, and another company has intelligence specific to like the things that Brazil cares about. And maybe they're like, oh, you know what? Let's just like exchange, like let's just have our AIs exchange information. Then I think those market forces, like the fact that you're starting from like 5 to 10 companies, will force some level of like protocol of exchange of information, which will start the decentralization process a little bit. And I think you're also not taking into consideration that there's a lot of, I mean, this goes back to my original argument at the beginning of this conversation here on stage, which is like, I think once these companies hit a certain scale, they would just not care about certain things that individuals in the world want to care about. A bunch of startups here, for example, there's a bunch of founders here who might agree with me, which is they're solving problems that large companies might not care about for a variety of reasons, and probably will never care about, and they're making a niche for themselves and building building value where even though a large company like Microsoft or Google is capable of building the same value, they have nearly infinite resources, they just don't. And I think you're gonna see some of that within these 5 to 10 companies. They're gonna probably want to partner with a bunch of smaller AI companies who are just operating in like a bunch of these markets, and then they're just exchanging intelligence bits over some, it's kind of like a decentralized partner network or franchise network or something of that sort.
What does that protocol look like? Is it just token space? Is it how is this exchange happening?
I would expect, considering like the protocol needs to be the common denominator, it would be something close to language, probably slightly more efficient than language, but not too far off.
What kinds of tooling do we need in order to prepare for a world with 1,000x more inference than right now?
1,000x more inference than right now. So let's say we roughly have about 10 million GPUs today in the world. 1,000x more is like 1 billion GPUs. On the backend side, I think the tooling largely depends on like how many kinds of GPUs and accelerators you would have. Now, like if at that scale, I'm pretty sure that NVIDIA is not going to be the only player. Even in the current market, like Google has found relatively good success, AMD has found relatively good success. And I think the backend tooling, like what kind of compilers you build, what kind of backend software what kind of inference engines you build, is going to largely dependent on how heterogeneous these accelerators are going to be. If every single hardware inference company is going to build roughly like a GPU-like thing, like by GPU I mean like NVIDIA or AMD, with a like maybe a matmul unit and like HBM, the standard structure, then I feel like the tooling is going to get very homogenized. Like, what you build would be like roughly like a compiler like, PyTorch inductor or XLA, and you're just going to add passes that specialize a bit to each of these hardware. But if you see innovation in hardware where like there's a variety of hardware all the way from like a Cerebrus-like system to like a NVIDIA GPU-like system, then the way you lower like your model onto an accelerator like Cerebrus is like wildly different than how you would lower it onto a system like an NVIDIA GPU, because the memory hierarchies are wildly different. Generally, how long it takes to compute something is wildly different. You got to model all of these things very differently. So then, like in that scenario, I think the tooling is going to be an explosion of like backend or compiler companies that are all trying to like vie for like more efficiency across these heterogeneous set of hardware, or like starting to specialize for like a whole family of hardware. So, and I think that's the same on the front end side as well. You have models, all these AI models that need to be deployed. The reason PyTorch is really successful today is because it understands that these AI models are still diverse and are going to be very diverse for the near future. Yes, they might be a transformer or a connet, but like the kind of transformer and how it looks is wildly different. If that is going to be true going forward in the next 3 or 4 years, then the front-end tooling is going to look a lot more like PyTorch. It needs to carry this weight of generality and take the model, allow the model to be fairly diverse as it goes all the way to the hardware. If we really centralize on like, oh, you know what, mixture of expert transformers are it. You know, like we achieved a certain critical mass of just those, and no one really wants to invest in R&D and modeling, then you're going to start to see more like Hugging Face transformers rather than like PyTorch, where you're basically like, oh, we don't need the kind of generality anymore because the world kind of is converging onto just a limited set of things. And you're going to probably just configure the knobs on these limited things via like simpler YAML files or whatever, rather than having a full programming language. So I can't really predict the future, but like if you were talking like 1,000x more chips, which is 1 billion chips, I would expect that many flops will have some level of exploration on the hardware side. And I would also expect there's a bit of a coupling. Now, let's say the world did centralize on particular model architectures. Suddenly, the kind of accelerators you build are going to change very rapidly. Right now, an NVIDIA GPU is very general. You know, it's not as general as a CPU, but it is pretty damn general, and that's what allows like a bunch of wildly different model architectures to be mapped efficiently onto this thing. Now, let's say you centralize on something like, you know what, we're just going to do MOE transformers of this kind, and like the world has just decided that's the standard. You're not going to pay for the generality in terms of energy costs and memory hierarchy. You're just going to build a chip that is really tuned to just map to that computation. So there's that coupling as well from like what models will get standardized to the front-end tooling all the way to the back-end tooling and to the hardware.
I think that's a surprising trend. I don't think a couple of years ago somebody would have anticipated that there would be much more decentralized or much more divergence in hardware because every single company is trying to build their own ASIC to get around the NVIDIA tax. But then that everybody will be trying to build the same kind of model. So that the front end, I think people would have expected that there would be like all this exploration of different architectures, but then everybody would still be using the same GPUs. And it seems like, and then in terms of hardware, there's also exploration that has to happen in terms of there's things which are best for inference and having low latency, like the Cerebrus and having high SRAM, and then there's things which are best for training and having high throughput. How much harder has your job become having to deal with all these different companies developing their own accelerators?
Quite a bit, honestly. Like, it's become more tedious just because there are just more attempts at trying to do something different, which I think is a good thing.
Yeah.
But largely what we spend time on is trying to convince hardware accelerator companies, which are coming up, to care enough about the software that they build in order that connects to PyTorch or JAX or whatever, that they need to care about sufficient generality. A lot of hardware accelerator companies, the way they're structured is they're run by people who are primarily like people who build great hardware. And so software becomes like a very minor consideration. Their basic premise is like, oh, we're going to build amazing silicon, and then everyone will just bow down to us and start using it because amazing silicon. But what happens in practice is like, maybe you built something amazing, maybe you didn't. No one knows how to use it. So like, no one's going to use it. No one's going to spend like 6 months in the hope that you built something great, which is why a lot of the more successful hardware companies coming up take software very seriously. So our job in the past few years has been like going to hardware companies that have promising hardware and convincing them that if they don't build their compiler to their hardware correctly, their hardware is dead on arrival. No one's going to just take it seriously anyways.
Speaking of compilers to hardware, CUDA and PyTorch have a similarly dominant position in their level of the stack in the software. CUDA obviously in the hardware level, you in the framework level. CUDA is closed source, PyTorch is open source. How do you think about what has made them dominant? Is there a difference? And what their edge going forward is? Which one is more likely to stay dominant?
It really depends on, as I talked to you about, the diversity of models. So CUDA is dominant primarily because, like GPUs are general accelerators, and if you have a software stack that can map a program to that level of generality, that software stack should have squashed like a long tail of bugs that users would have seen, and like the software has sufficient polish that on average, if a user uses that software, they're not gonna just be blocked by like bugs in software, right? Like, so a general piece of software that is pretty mature, having matured over 15 to 20 years, that's what CUDA is. For anyone to build another piece of software at the CUDA level, with that level of software maturity is hard because that software involves a bunch of generality. I think there's not a lot of like ways to cheat your way into building something as good as CUDA by a competitor. You can build something as good as CUDA very quickly if you narrow down your problem. If you say, oh, we're not going to tackle all of the generality. Our software is really going to tackle this one segment of the market. And within that segment, we build something as polished as CUDA. But like, if you want to tackle all the generality of CUDA, you just got to do the hard work of squashing like the long tail of bugs, unless maybe like AI will help you squash the long tail of bugs and accelerate like the development of equivalent software very quickly. PyTorch, on the other hand, I think is a lot more vulnerable to the standardization in the industry. If people just, I mean, we already see this today. Okay, if there's a room full of like AI hackers, I go to hackathons all the time, and we ask them like, okay, how many of you guys like use like Llama or something like that, and like a bunch of people raise their hands between Llama and DeepSeek and all of these models, and then you're like, how many of you have run them? And they're like, all of them raise their hand, and then like you ask them, how many of you have heard of PyTorch? Like literally like 30% of the room raises their hands. Like 70% of the people run PyTorch and don't even know that PyTorch is a thing. They're just like, I don't care. In the same way that I don't care what version of Linux kernel is running on my server. Like, it's just commoditized to a lower level of abstraction. So I think PyTorch is a lot more vulnerable from that sense. It's like the number of people who care about building a model versus the number of people who are consuming models that are just published is very disproportionate now. It used to be like very like 1:1 in like when AI was like a smaller thing. But as AI is getting commoditized, a lot more people are consuming AI models than are building. So the people who are consuming models don't care about PyTorch at all.
Yeah. Who are these AI hackers who don't know what PyTorch is?
Oh, I mean, there's a lot of people. I mean, think about, there's a whole generation of AI hackers who only use like the APIs.
Right.
In that case, like, they don't even know what a transformer is. They're like, I don't know, I use that AI model. And that prompt's great. Like, I adjusted the prompt and it's like fantastic. That's really abstraction level that they're working with, which I think is like amazing. But at the same time, they don't.
Or if they do use an open source model, they'll use the Hugging Face library.
Yeah, they're just like, I don't know, I clicked some buttons and like, it came through.
Well, actually, that's another question. You've talked about the benefits of open source in terms of decentralization. But if the trajectory is that we have these big MOEs where you can't run them on a single GPU, and maybe you can run them on a node, but the throughput is terrible if you're not batching them and you're just using them personally, isn't the future that even if they're open source, individuals are not really making use of them? And if that's the case, like, what is the benefit of decentralization really, right? Like, it's like you're not running the best models on your MacBook. So then what's really the difference between open source and closed source at that point?
Decentralization is fundamentally about agency. It's about whether people, companies, societies, countries have agency or not. So you're right that like if you have like a giant MOE that only runs on like 2 H100 servers or something, then an individual cannot run it. But you do get the other entities I described, like countries getting agency is a huge deal. Companies getting agency. Okay, let's say like there's OpenAI and like you want to create a competitor to OpenAI. Like with open models, you have agencies to start from an open source model and then go from there. So I think like the agency to like use these models in ways that you generally don't expect, I think just that agency itself is extremely powerful. And the second thing is like you can always distill these models, and like a bunch of individuals are probably like, you know what, if I like distill this giant MOE in order to run on like a singular GPU, that is going to be impactful for all of these like individuals who want to use local models for whatever reason. Like, I mean, people have weird and wild thoughts, and they probably don't want to put it into like ChatGPT. And even if they put it in ChatGPT, they probably, it probably will tell them like, no, I'm not going to answer this. I think there's a certain agency people should have as humanity. Of course, it has to be balanced with safety and other social considerations. But I think decentralization, even if you release like a giant model, is going to be pretty powerful, like in ways that I just described, like for individuals, for countries, for companies that are not as big.
We need ChatGPT incognito mode.
I think it has one, but you never know whether they're actually like...
Yeah. Well, it's true of the normal... So this is maybe an argument for why philosophically or in principle it might be good for the world to have open source. But what is the reason to expect that the company which is at the frontier, or one of the companies which is at the frontier, will continue to open source? So what is the sort of, other than maybe the CEO of that company sort of caring about it for intrinsic reasons, what is the economic incentive that they would have to help other companies catch up to the frontier or have their own autonomy, to help other countries have their own autonomy. Why would we expect open source to continue being a player for purely sort of economic incentive reasons, short of that just being in the value system of one of the CEOs who has a leading company?
Yeah, I think like a lot of companies want to commoditize their complement, right? Like it's just true that if you have a central business and you have all these other things you're doing anyways that don't affect your central, your revenue model, and that would effectively commoditize a bunch of competition's ability to leverage those things, then you want to commoditize it. Like that's just like a sound business argument. It has nothing to do with philanthropy or evangelization or trying to do good for the world. Commoditizing your complement is just like very sound business strategy. And I think that's just going to be true regardless of like, I think like Mark Zuckerberg sees this, and like I think 4 halves ago, like even he even stated the whole thing, his strategy in an earnings call. He's like this is just net good for Meta. This is not something like that like we're doing out of doing good for the world or whatever. So I think more CEOs should be smart enough to see it and care about it. But like I think that is going to be one part of it. Like there's going to be companies that are going to want to commoditize the complement. Secondly, there's going to be geopolitical things as well. I mean, if you have a national program where, okay, your country, let's say, take some country, any country. I'm not going to give an example because it's going to be miscoded. But take a country, let's say they're behind in like AI as a country. Then the most effective way for a government to try to boost it is to try to like create technology and like open it very quickly. I mean, that's just been true in many other industries in terms of national strategy. And I think it's going to be true within AI as well. A bunch of countries will want national strategy where like they're giving away AI to all of their people. So I think just like geopolitical and like companies commoditizing their complement are sufficient enough market forces for open source AI to just continue being a thing.
But it seems empirically that the trend has been kind of the opposite, where the gap between something like Llama 4 and the best closed source models, I think over time, like the Llama versus the best open source models has increased. And if you look at even at countries supporting models, so like look at France and Mistral, I don't know, like who is,
Yeah.
Yeah, so it just seems like it's hard to make a sort of a tertiary part of your business something which competes with companies which are making it a primary thing, especially as AI development gets more expensive and more difficult. So I feel like going forward, I would expect a similar dynamic, where I'd be surprised if Russia or Nigeria or somebody can just decide, well, we want to be in the AI race, and so therefore we're going to make an amazing open source model.
Yeah.
I think it sounds like it'd be, I wouldn't like bet in their favor in that.
Yeah, they probably wouldn't, but they would certainly form a coalition to try to be more successful. I mean, EU is an example of that. Like it's a coalition of countries trying to progress economic interests together. That has been reasonably successful. I mean, your example of like, will Russia and Nigeria like individually try to compete might not be true, but you can have a coalition of African countries, including Nigeria, who are trying to make progress on it. I can certainly see that working out. There's a lot of like unknowns here, which is why I think it's hard to really resolve a particular direction. But considering, I believe that companies, as they get large and bloated over time, will just slow down and will like be outcompeted by other companies, unless there's a fundamental moat. I mean, if you see Google search, like everyone's just used to Google search, so it's really hard to like decouple from it. And Google search has a bit of a flywheel effect, so it's a bit hard for others to decouple, to topple search. I think AI hasn't quite reached a product mode in the same way, and there's a lot of companies competing with both intelligence and productization. As long as the competition is, as long as the moat for these companies is purely intelligence and not so much like the product interface or how sticky like the overall product is, I feel like mostly intelligence is not very moaty. People will just switch to a different provider very quickly if they find a more intelligent model. As long as there's no real moat that is formed, I think all kinds of coalitions, collaborations, and all of these things will keep the incentive to share data. Like I was given an example of like franchise models. Like, I think we're on day zero of AI commoditization. I think we're going to see all kinds of models, especially as the current leaders start to mature and saturate and run out of ideas.
I have a take about why these models haven't been as economically transformative as somebody a couple of years ago hearing about them on paper might have thought, and I want to run that take by you and get your sense. So sometimes people say things like, well, the reason the Fortune 500 isn't adding LLMs into every stack of their workflow is just because of the stodgy management. And I don't think that's the case. I think it's genuinely hard to get human-like labor out of these models. And I think a big part of the reason why is their lack of continual learning. I've tried to use these models to automate different parts of my podcast production workflows, like rewrite this transcript in the way a human would write it, or find clips or something. And there are 5 out of 10 of them at these kinds of tasks. They're okay at it. But these are just tasks which are dead center in what you would expect to be the LLM's repertoire, right? They're like short horizon, language in, language out. They don't require a bunch of context. And while they're mediocre at them, the problem is that they don't get better over time. You basically you're stuck with the abilities you get out of the box. And if you think about what makes human employees or human workers so valuable, it's not mainly their raw intelligence, it's their ability. I mean, anybody, even who's super smart, just like joins the job the first day, they're just kind of useless. It's their ability over time to build up context, to interrogate their failures, to understand what's going on in their industry, in their workplace. And so I think this like lack of continual improvement will really limit the economic value of these models. I don't know if you
I kind of agree that continual improvement is one of the things needed. There's a few others. From a purely technological point of view, right? Continual improvement is one thing. Just the ability to not fail in ways that are very hard to predict is another. Like if you actually today's models, if you ask them to take 100 actions, one after the other, there's a very good chance they're just going to fail on action 47 randomly in a way that a human never would. It's something as them as like, okay, go find like yellow couches online and make me a list of like 200 yellow couches and like pull up their URLs or something like that. Then this amazingly intelligent model that can tell you all about world history and connect all these dots that you find so hard to connect is just going to go to a website and will just get stuck from like the discount banner that pops up and be like, I don't know how to close this thing, right? Like it's I think like people are finding it hard to integrate AI models into enterprises because they're trying to do it in the same way they onboard a human.
Right.
And these models have a very different failure characteristic than humans do. Continual learning is one thing, just their overall context, like their ability to succeed on a bunch of discrete actions is another. The third thing that I think is generally very underrated and not discussed is like, I think a lot of humans are hired to be responsible for a certain thing. Like, there's a lot of like responsibility and negotiation that goes into a given job function. So let's say I hire someone, I want them to take care of a certain thing. Now, like, how they do it is not my purview. Like, I might have an opinion of like, hey, can you use this technology that we have available? And I will give them feedback on like how they are like executing, like whether they're actually like doing the job responsibilities well or not. And I think with AI, the fact that the AI doesn't give a shit about whether like it did your job well or not, it's just gonna be like, I'm sorry, I failed. Like, it doesn't have like, what are you gonna do? Like, give it like performance feedback and like reduce its bonus, or like
You did a very bad loss.
Yeah, it's like I think like that is a big part of like employment.
Yeah.
Like businesses especially as they grow larger, want people to like take responsibility of a whole thing. And I think with AI, we don't quite know how to model it, which is why I think a lot of AI integration is more like, hey, like we're just gonna need lesser humans for the same kind of responsibility, rather than just being like this whole thing will go to like an AI.
Yeah, and I think the responsibility thing is actually quite linked to this online learning, because when you do make somebody responsible for something, what happens over time is that they keep building this like rich context in that domain. So over time, they just become the world expert in how to deal with this kind of particular problem, with the kinds of people they have to deal with, the kinds of situations they've dealt with in the past. And that just isn't possible if the session memory is extinguished every single time.
Yeah.
And yeah, I think that's one big bottleneck.
And I think part of the whole delegation is you trust another human based on however you got signal that this person is fit for the job,
Right.
or whatever. As I was describing, we don't know how AI is going to behave in a lot of situations. With a human, you kind of do all kinds of correlations. You're just like, well, this person like trained for this job, or like this person like we have all these silly things that we're trying to get rid of, biases, which are like, this person is able to speak well, and hence they must be just good at doing this job, even though like the job has no correlation of speaking well, or they went to Oxford, so they must be like,
Right.
So I think like with AI, we haven't really established like how to think through how the AI is going to behave.
Right.
And so we also need to make progress on that.
Yeah, I mean, we've been talking about the disadvantages these AIs have currently as compared to humans, but it is important to emphasize the advantages they have, because eventually these limitations will be taken out, and then what we will be left with is at the very least human level abilities across everything, except for because they don't have biological brains or the constraints that humans have, they will have certain advantages that we can just sort of predict. And one that you can already see in these models is this ability to, at the beginning of the session, even though they don't have the memory of their previous sessions, their ability to like pick up context, to read every single Slack message and every single line of code in your repository, every single document in your Google Drive, is just like super powerful. And the fact that you can just onboard 1,000 coders at a moment's notice. And right now, obviously, they can't really generalize or preserve that, but it feels like today it's sort of like having a gun turret and you're like bringing it to war, but you really can't aim it at all. Like, it's stuck in one direction. And then if you happen to have the task you need dead center in the aim, then you can just like fire away with like 1 million terminals with Cloud Code or something.
Yeah.
And if it's not, then you're fumbling and you have to go back to human labor. But once the sort of like maneuverability of that increases and generalizes, I think it's underrated how big a deal, like they will actually be much better at onboarding than humans.
I think it's true. I think but I think like one of the things that is also underexplored is like how much of real world value is going to be bottlenecked by not by intelligence. So, I mean, we're talking about, like there's the economy is, intelligence is one of the central factors to economic value. And we're basically saying, if we make intelligence too cheap to meter, then the economic value that is provided by intelligence is going to be reduced, or whatever. It's going to be centralized to the companies that are providing that like superior intelligence. But that's not the whole job. So let's say the job involved, I'll take like drug discovery, drug development as an example. I mean, like, I think AlphaFold came out, a few years ago. It's definitely like transformed the overall process of drug development or like general biological research. But if you actually like, Zach Weinberg, who spoke to Des Morning, and generally the Curie folks, I hang out with them a while, they basically say, yeah, if you actually look at the overall process of drug development, there is this one step that used to be like bottlenecked by like intelligence, and it's now replaced by like a very good AI model. But then now, like in the overall process, you reduce like the development time by like 3%, because like the rest of the process is not really bottlenecked by intelligence or technology per se. So I think there's not a lot of good, thoughtful analysis among AI doomers or like AI economic doomers on like if intelligence is no longer the bottleneck, what would be the next set of bottlenecks? Maybe they would just be like, yeah, like we solved like the intelligence part, but then somehow in the overall scheme of things, like the value that like the overall efficiency gain isn't as much as we expected it to be. So you still need humans in the process for whatever reason. So I think that's like a bit underexplored, and maybe the reality might just be like, we thought AI will take over jobs in 5 years, but it took 50 years because like we needed all kinds of changes to real world systems.
Final question. The amount of work which you get done now in a week, how much longer would it take you to get that amount of productivity done if you couldn't use LLM-based assistants or tools at all?
Man, this is a very good example of my previous point. Like I am able to get way more done of certain kinds of functions now than I used to. Like I heavily use all kinds of AI to aggregate information, to select information, to even do research of all kinds of things. But there's many other things that are just not like made more efficient by AI. Like, I mean, I'm just talking to other people. Like
the AI can't come to this event for you?
Yeah, I mean, this event probably is an example of, it's possible this event would have been like replaced by me just, honestly, all the answers I gave, an AI probably could give. I don't think I'm that insightful, but like just making progress on like, on the job. I have like 20 hours of meetings a week where people expect me to show up and take decisions and like argue with them and all of that. I think, let's say, like maybe I used to spend 20 hours a week on meetings and 40 hours a week on like all the other stuff, coding and research and all of that. Instead of 40 hours a week, maybe I'm spending 30 hours a week on the other stuff, but this 20 hours of meetings still exists. So I think like, I don't know when I will get to a point where like those 20 hours of like intangible meetings as of today will reduce down to like, oh yeah, like my AI model talked to your AI model and we aligned on like how we're gonna make this project go forward. Like I don't know how far we are. Maybe we even need a whole 1 or 2 generations of people to effectively enter the workforce, where like they're just like growing up with AI as like a fundamental auxiliary thing. Like, you know, like we grew up with the internet as like a given. Maybe like until whole generations of people like enter the workforce, like you're not gonna get rid of like meetings in the same way.
This is fun.
Yeah.
Next year, the RAIs can talk to each other.
Yeah, I think like, you know, have your AI send me
The questions. And your AI will do the research and prepare them. Yeah, that's right. Cool, thanks.
yeah, of course.